I know. You want to hit that job at software engineering. I know you want to enhance your skills. Keep watching these videos and try to solve these problems. Even if you need help, it's okay. So, hello everyone, welcome back to my channel. Today, we are diving into LeetCode problem 199, binary tree right-side view. I'll be breaking down my solution to this problem line by line so you can understand how it works. Let's jump into it. Anyways, it's a binary tree right-side view. Given a root of a binary tree, imagine yourself standing in the right side of it. Return the values of the nodes you can see all the way from the top. So, the problem statement goes like this. Given a binary tree, you need to find the rightmost value in each row of the tree. You can do this by returning an array of integers representing the rightmost node in each row. If the tree has only one row, then return an array with just one element. To solve this problem, we'll need a depth-first search DFS algorithm with a slight modification to ensure we capture the rightmost node at each level. Our strategy involves traversing the tree level by level, keeping the track of the current level we are at, and updating our result whenever we reach a new level. Anyways, here's the code we'll be discussing today. Let's start by examining the class and method definition. So we have here a solution and a right-side view function. We start by defining it. Then we start by defining another function, root, giving it 3 arguments. Root, result, and floor. If root is none, return. Inside right-side view, we define a helper function called try. This function is responsible for traversing the tree. It takes 3 parameters, root, result, and floor. The first check here is if root is none, which means we've reached a leaf node, or the tree is empty. In such cases, we simply return from the function. So next, if len result equals floor, result point append root point file. Next, we check if the length of the result list is equal to the current floor. This is important because we only want to add a node value to the result if we haven't added any value from this level yet. This ensures we capture the rightmost node at each level of the tree. So we go next. Here we have a recursion. Root point right, result, floor plus 1. To solve tree problems, you need to be familiar with recursions. Result, floor plus 1. We go to the left and to the right. We then make recursive calls to try first with the right child and then with the left child of the current node. We increment the floor by 1 with each recursive call. This way, we traverse the tree level by level, always exploring the right side. Anyways, then result equals an array. We set an empty array by root result level 0, return result. So before we call try, we initialize an empty list called result. We then call try, starting with the root of the tree, an empty result list, and floor set to 0. After we traversal, we return the result, which now contains the value of the nodes visible from the right side of the tree. Okay, I have a small problem. The problem is right here. Let me see what I have done wrong. Okay, this is the problem. I just called it wrong. So it is as efficient as it can get. If you find this breakdown helpful, make sure to hit that button, that like button, and subscribe for more LeetCode problem solutions and coding tips. If you have any questions or want to share your own solution, drop a comment below. Thanks for watching and see you in the next video.